Thank you everyone for joining today. My name is Fawad Khalik, and I'm an engineer at Plumb. And today we're going to talk about Docker networking in OpenStack and what are some of the aspects that networking offers in the container space, and specifically for Dockers today. The background over here is that at Plumb, a lot of people have come and asked us about how to manage this explosion around Docker containers. I mean, this technology is picking up this momentum in a way that it's being adopted all over the place, and networking is something which is not being looked at, and it's something which has a lot of questions which people don't know the answer for. And they have come to Plumb, and we have tried to solve and provide them information in a way that they can, have better understanding in this space. So with that, I'll go over a brief introduction about myself. I've been a member of OpenStack community for a few years now. I'm also a developer in Neutron, Nova, Docker, and Magnum projects. I'm also the maintainer of Plumb Neutron plugin. If any of you would like to get in touch with me, has any questions later on, please feel free to reach out to me or this my email, Twitter, or IRC. So today we'll talk about Docker. What is Docker, and why is it being rapidly adopted in the industry? What are some of the use cases that Docker offers, and the industry is using them today? What is the status of Docker inside OpenStack? We have Nova, we have Heat, and we have Magnum. How does Docker look as the part of OpenStack ecosystem? And what is the state of Docker networking since Docker has been introduced natively, how it has improved over the past 2 years, what is it that is today, how does the Docker networking look like inside OpenStack, and then we'll go over how to have common or unified networking for containers and VMs in OpenStack through Neutron. And in the end, we'll go over a demonstration of this unified networking model. And then, of course, we'll talk about some of the key takeaways from this presentation. So a brief introduction about Docker. Container technology has not been new. It has been there for a long time. Tech giants like HP, Oracle, IBM have been using them for years. And now this new technology called Docker has completely redefined the way we look at containers. This, to me, is like a common packaging format for cloud applications, or like a standard API which can be used to provision containers which allow you to have this ability to run processes in isolation. So I have to summarize what is Docker to me. Docker to me is like a mature technology package to be easily consumed. And as a result, it's no surprise it's a huge adoption in the industry, just like OpenStack. And if you look at the numbers over here, these are stunning numbers. And we're looking at over here is like 100 million Docker engine downloads, like 45,000 plus applications in Docker Hub. There are like 800 plus community contributors for Docker, and around 25,000 plus GitHub stars. This shows how the industry has already embraced Docker technology, and it's moving to the next level now. And all these stats are coming from the last year, which has been a great year for Docker. That is 2014. What's the reason? Why is this explosion, and why is it being adopted? Docker or containers, they're lightweight. So Docker or containers are extremely small size, and they boot extremely fast in milliseconds versus virtual machines. And that's why people are using them. You could spin up thousands of containers on a host and still be able to run all of those applications and have your use cases fulfilled, versus the virtual machines where you'll have the hypervisor layer and you're running all sorts of extra things like emulating hardware for your VMs and things you don't even need. But in the Docker or in containers, what you have is very specific applications which are running all the resources abstracted from your operating system in a way that you're running bare minimum, which are satisfying your use cases, which offer you easier management of your binaries and libraries and the life cycle of your applications. You can have these shared on your operating system. So what you're looking at over here is the comparison between the way VMs work and the way containers work. And containers, of course, are lightweight and pretty fast. So if you talk about some of the use cases of Docker, what we're looking at over here is these are ubiquitous use cases. You could swap them one-on-one with virtual machines. I mean, use cases like continuous integration, continuous delivery, paths, they have been there before container days. I mean, you could use them, or you could use bare metal or VMs to actually spin up these use cases. What is common across all of them is the rapid deployment model. And this is where the added value of containers or Dockers come into the picture. So for us, we need to look at containers or Docker in a way we used to look at VMs and bare metals. And it's even more important when we talk about the networking, because the problems and the challenges and the things that we need to make sure that our networking for applications is production ready are going to be the same that were there for VMs and bare metals for the Docker as well at this point, and they will be. So let's talk about the love between OpenStack and Docker. Docker has been part of OpenStack in different shape and forms. The three main areas where Docker is part of OpenStack, where you can use Docker as part of OpenStack today, is through Nova. So in Nova, Docker works as a compute driver, just like libvirt works in Nova. So you can spin up containers as Nova instances. So what you're looking at over here is an overlap of functionality between Nova and Docker. So Docker has some feature set and Nova has some APIs. But all the Nova APIs which are exposed over there are not supported by Docker. And similarly, all the feature set that Docker has is not exposed by Nova APIs. So for example, Docker supports linking containers, passing environment variables, specifying working directories, creating Docker volumes, things like arbitrary commands, pass devices. Those things are not exposed as part of Nova. Similarly, there are things which Nova does, like supporting mounting devices, live migration, PCI pass-through. All of those things are not supported by Docker. So what we look at over here as part of Nova is an overlap of functionality between Nova and Docker. So Nova Docker is a driver which is in Stack Force today, and there are discussions going on to bring it back inside the Nova Compute program, but this is what works today. Then second, Docker can be used as part of heat templates. So what you can do is provision these containers inside Nova VMs and using these hot files or hot templates, which are heat templates, to actually launch containers or Dockers inside VMs. But this is, fire and go model where you can have a template, launch it. There's no resource scheduling. This doesn't work like Kubernetes on all the other orchestration systems. So it's very specific use case. It doesn't offer you a full-fledged solution. And then we move on to the Magnum. Magnum is a project in OpenStack called Container as a Service. And just like you have Nova to launch VMs, you have Magnum to launch containers and manage containers and their lifecycle and all the use cases that containers offer. So Magnum integrates with Keystone and Heat and other services seamlessly. It is multi-tenant. It offers you async APIs, and it has the concept of node and a bay and pod and container and replication controller. So these are some of the contents that Magnum has. In this session, I'm going to talk about Nova aspect of it, because that's what works today. Magnum is in early stages, and Heat something is something not there for the lifecycle management of containers. So I'll consider Nova and Magnum to be the ones which are in a shape to provide some networking aspect and other details. So with that, I'll give you some background of how the networking has been past 2 years for the Docker containers. So when Docker came out, the very first thing which was supported was the one and only, the most popular Docker Zero Bridge. So Docker Zero Bridge is a Linux bridge, which is like an L2 learning switch built into the kernel. And in this model, what you have is each container has a specific IP address, and containers can talk to each other over this Linux bridge. And your host can talk to your containers over this Linux bridge as well. And you have IP tables to do some extra functionality if you want to go out of the host and all of those things. Then you have another model where you want to have your containers talk to your containers over Unix domain sockets. So Unix domain sockets are like a file descriptor-based communication, which is restricted to one host. And that's another one of the ways you can actually have networking. Then you can actually have the ability to provide full host network access to your container. And then at that point, your host can talk to your container over the loopback, and your container, in this case, has the ability to listen on some privileged ports. One thing which is common across all of these three use cases or ways to provide networking for Docker in the past is that this is very primitive. If you take it to any network admins, they will not feel comfortable with it. And the good thing is that the networking folks for the container or Docker have realized this has to be improved, and they've come up with a new model called a container network model using a new abstraction called libnetwork. So libnetwork is just like libcontainer or libswarm. This has been designed in a way that you have a common API, and that common API manages this model called CNM or container network model to actually allow you to provide networking for Docker containers. So there are three main terminologies that are used as part of the container network model, and those that you see in the diagram over here is a network sandbox, an endpoint, or a network, and a network. So a network sandbox is like an isolated environment where networking for a Docker container resides. And an endpoint is something like a network interface where a container or Docker can communicate over the network. And a network is a group of endpoints where different endpoints can talk to each other. And one network is isolated from the other network. So libnetwork is like a common or standard API, just like Neutron. You have common API, you have libnetwork, which provides a common API. You have this notion of drivers and extensions, where you can have different implementations come and get plugged into this libnetwork model and do the actual backend implementation of networking. So you could go to a driver inside libnetwork and say, provision a network for me, and it would actually go and provision a network for you. Let's say a plumb driver over there. And then you say, create a container from the other API and then attach my endpoint to the container and also to the network. And you would have networking. So that's how libnetwork would work. And this is under heavy development. It's in very initial stages. It came out 4 weeks ago, and it was announced. And now it's something which is being developed. I'll briefly talk about Neutron, since I would like to do some comparison later in the webinar. So Neutron has a pluggable model as well. You have this notion of plugins where you can go and plug some backend technology. In this case, what we're looking at over here is a Neutron API with a Neutron plumb-grid plugin, which talks to a Neutron with plumb-grid ONS backend, or Open Networking Suite backend. So whenever you go to Neutron and say create network or delete network or create port, delete port, that call actually goes to the Neutron plugin, and Neutron plugin calls the ONS backend to actually do the operations. So that's how plumb-grid provides the networking for all the workloads inside the OpenStack ecosystem. You can have on-demand networks. So as you see, the comparison between Neutron and libnetwork from a provisioning point of view is there. You have one API which does it all, and you have this pluggable architecture. Since most of the people are familiar with Neutron model, I would like to do some comparison here. In the container network model, we have this notion of endpoint and a network. In Neutron, we have this notion of a port and a network. So an endpoint would map to a port in Neutron. A port is something which is attached to a VM, and VM can communicate over the port to the network. A network is something, an isolated entity in Neutron, which is like an L2 broadcast domain, and this maps to one-on-one with the CNM model. And this is where I would say networking has to be unified in a way that you have containers and you have VMs. You should have one networking layer to manage it all. And we'll talk about how this is being solved in the OpenStack community as well. And why do we have to solve networking in a way that you should not care about if you have VMs or you have bare metal or you have containers? Let's talk about OpenStack ecosystem. You have Nova to manage your different compute nodes. And let's say you have libvirt to spawn VMs, and you have Docker engine as part of Nova to launch containers. And you have Neutron, which is one networking layer to provide networking. So in this case, some of the use cases, you could think that I have some application server or web server, which I want to be elastic up and down in the cloud. And then I have some databases, for which I don't trust the security models of containers today, and I want to launch them inside the VMs. So that's one example, one of the hundreds of use cases, which I've enumerated here in a way that you can have VMs and containers running at the same time as part of OpenStack, and you could connect them using Neutron networks that you see over here. Then you can have communication from container to container, from container to VM, from VM to containers, all sorts of permutation and combinations. When we go to Nova Docker driver, and Nova Docker driver is actually containers as part of Nova, how does it exactly work? We know how libvirt works. When we spawn a VM through Nova, VM comes up and it gets attached to a Neutron network through some backend binding of the virtual interfaces. The mechanism for containers or Docker is exactly the same. It works exactly the same, and I'll walk you guys through over here. Let's say you go to Nova and say provision or launch a Docker container through the Nova API. The call goes to the right compute node, in this case, the compute node which is running the Docker engine. The compute node talks to the Neutron API to request a port which is associated to a network which is specified as part of the VM when you launched it. Then for the port, the create port call goes to the Neutron plumb-git plugin, and plugin plugin calls the ONS backend. At that point, your create port call has been completed, and you have a port in the hand of Nova Compute, which actually can take it to the Nova Docker driver and request for a VIF, a virtual interface binding to the backend. In this case, plumb-git ONS backend is there, and you actually connect the VIF through the Nova Docker driver, which has some code over there, which we have pushed in the driver to connect to the backend. Once that is completed, Nova Docker through the Nova Compute and Nova API, which launch Docker container, which will be connected to a tap device already. And at that point, the container or the Docker will have connectivity over a network, which is provisioned by Neutron. And I'll go over that part in the demonstration as well. So the question is, well, I'm giving some theoretical aspects over here, but does it even work? I mean, is this real? The answer is yes, this is real. And I'll go over a demonstration of exactly this, where we have VMs and Dockers, and we show networking through Neutron and plumb-git, and then you have common way. So in the demo setup, what I have is the latest and the greatest. Kilo running with DevStack. I have two nodes, two servers. One server is running a controller and a compute. The other server is running a compute only. One server is running a Nova Docker driver. The other server is running a Nova libvirt driver. On both these servers, I have some plumb-git services running to support the networking. What I have over here is, as part of Kilo DevStack, I have Neutron configured with plumb-git ONS plugin. So this entire setup is capable of doing all the use cases from a container and VM and networking perspective. I will go over those. So what I'll be doing in the demo will provision a private network, which is the L2 broadcast domain through Neutron. I'll spawn a VM and a Docker container on that same network. I'll validate connectivity across these two Nova instances, which one of them is going to be VM, one of them is going to be a container over this same L2 domain, which is going to be these VMs and containers will be living on different hosts. I'll create a router and connect to the private network, and we'll check connectivity with the external network. That's a ping Google DNS, a ping OpenStack.org. And then we'll associate floating IPs, check connectivity from outside to inside, and then we'll play a little bit with the security groups to see how that affects the topology. What we will have in the setup will be two physical servers. One server will be running libvirt compute. Other server will be running a Docker compute. Let's say in this case, you have server 1, which is running Docker compute with a Docker container, and you have server 2 running libvirt compute with a VM. If you see in the physical view, at the bottom of these servers, you have a physical network. So a physical network is something, a switch, a top-of-the-rack switch or something, where all of this communication is happening through one NIC between these two servers. Then logically, on the upper side, you have a virtual network, which is provisioned by Neutron, which shows you that your container and your VM are connected to the same Neutron network, and they're able to communicate as if they're sitting somewhere on the same place. And then you can connect your Neutron network to a router, and then router over to the internet for floating IPs, etc. So we'll go over that in the demonstration. So with this, I would like to start sharing my screen, and we'll go over the demonstration. Okay. So for the demo, what I'm going to do is I have the OpenStack dashboard, which is also called the Horizon, and I have the plumb console. So I'll be using these two user interfaces over this demo to show what can we do for container and VM networking in a homogeneous or unified way. So let's look at the system view as the first thing in this setup. As I mentioned, I have two compute nodes. So in the list of hypervisors, what we see is one of them is of type Docker, and the other one is of type QEMU, which is running libvirt. And both of them have 2 vCPUs, RAM, and some storage, etc. What I have done is I have provisioned host aggregates as part of Nova, which is I really love this feature. So what you can do is you can provision host aggregates, and you can define a group of compute hosts to be part of one availability zone, and a group of compute nodes to be part of another availability zone, in a sense that when you spawn VMs from Nova, you can specify where to schedule them. So let's say in this case, you have some group of hosts which are running Docker and some group of hosts which are running libvirt. You can do the scheduling in a way that it makes sense. So you have one host each on each of these availability zones. Now let's go over the images that we have. So Docker engine would want to have an image which is compatible with it. And similarly, libvirt would want to have an image which is compatible with it. So I have two images. The one which is labeled libvirt Cirrus will be compatible with libvirt version or libvirt compute node or libvirt driver. And then the one which is just Cirrus is compatible with Docker engine. We'll see how that works in the demonstration. So this is with the hypervisor and the host aggregates and the images that I have. Now let's see in the plumb console, how does the zone look like, or the system that I have. I have two compute nodes, and how does it look like from the user interface point of view. By the way, plumb UI or plumb console is just for looking at the information, how it looks like from plumb perspective. We'll be doing all the operations from the Horizon and Neutron, and this is just for the visualization. Some extra things which is not exposed in Horizon. So what we have over here is two compute nodes, and we see them as part of plumb zone. So now I have created this project in this setup, which is called Docker Networking Demo. Let's log into this project, which should be empty at this point, with just a simple Neutron default security group. So there are no instances, no vCPUs, nothing is already provisioned at this point. And if we look at the network topology, we just don't identify anything. The external network is something which is public, which is pre-provisioned as part of the setup. Similarly, if we go to the plumb console, we have this notion of virtual domain, which maps to a tenant in OpenStack. So if you go to the virtual domain, which is called Docker Networking Demo, what we see over here is an empty topology, and we just have, of course, the default security group, which gets created when a tenant is created as part of OpenStack. So now let's go and provision a network in this setup and a subnet with a DHCP. So let's call it Docker demo network. And let's provision a subnet as well, Docker demo subnet with the IP 192.168.0.0/24. Let's make sure we have a DHCP enabled so that VMs can get or containers can get IP address using static leases. So at this point, what we have is a network and a subnet provision from Neutron, and we see it in the network topology. If you go to the plumb grid console, we see a network which was created from Neutron popped out over here and with the same name and the DHCP instance. Now let's go to the compute. If you look at the list of instances, we don't have any instances running at this point, and we'll provision those. So what I have is 2 compute nodes, a Docker compute and a libvirt compute. So these show that this is running libvirt and the other one is running Docker. So we can run docker ps command to see if we have any containers running at this point. We don't, it's an empty list. Let's run worst list on the other one to see if we have any VMs. We don't. So at this point, this shows that no VMs in OpenStack and no VMs in the compute nodes. So now let's provision a Docker container first and see how that looks. So if we go to Nova Horizon part, dashboard, we choose the availability zone, which is Docker availability zone. Remember, we went to the host aggregate part, and over there, we actually provisioned a host aggregate, which had the correct compute host, which was running Docker engine. So we pick that availability zone. We pick a name of the Nova instance called Docker1. Remember, I mentioned we had the image, which is called Ceros. This is compatible with Docker engine. So when we provision using this one, it will work. We go to security groups, use the default one, and in the network, we use the network which we created a minute ago. So at this point, my container should be up very soon. It is up and running. It is part of the Docker availability zone. It has an IP address 169.192.168.0.2. So now let's go to the compute node, which is running Docker engine. So if we do docker ps again, we see a container popped up here 15 seconds ago, and its UUID looks something like 3B2EE, starts with that. And let's compare that with the UUID inside Nova. And that seems to match what we see in the compute node. Now let's look at the interface configuration for this container. So we do docker exec, pick the container UUID, ID, and let's do ifconfig. And what we see over here is the container or Docker got an IP address which matches the one we see in the Nova, which is 192.168.0.2. So now let's go back to Horizon and launch a VM. In this case, we'll pick the libvirt zone, libvirt availability zone. I'll pick the name VM1. And in this case, see, I'm going to choose the image, which is called libvirt0. So it's just compatible with libvirt. Pick the same default security group, same network I created 3 minutes ago. And at this point, my VM is active again as well. This VM has an IP address 192.168.0.3. If we go to the libvirt compute and do worst list, we see that an instance is running here. And let's compare its UUID with the one inside Nova UUID to make sure that we are looking at the correct instance. So we do worst up XML, ID of the container, get for the UUID. So the UUID that we see over here is 303.855, and that matches the one we're looking at in the compute node. So now let's look at the network topology. And in the network topology, what we see is that we have one L2 broadcast domain, a Neutron network, which is connected to two Nova instances. One instance is a Docker, another instance, the other instance is a VM. Nova does not differentiate visually between a Docker and a VM. But if you go to plumb console, we see that a Docker is on your right side, and a VM is the one which I just dragged onto the left side. So that's the group of VMs, and that's the Docker. So now let's go and open the console for this VM. I think let's go over to the compute side. Let's open the console for the VM. Let's look at its IP address, and then it's going to be the moment of truth. We check connectivity using the state-of-the-art ping utility. Let's do ifconfig. So the IP address VM has is 192.168.0.3, which is the same as the one we saw in Nova. And now from here, let's start pinging the Docker, which was 192.168.0.2. So I see the traffic is going through. From the VM, we are pinging 192.168.0.2, which is the Docker. And now from the Docker, let's ping the VM, 192.168.0.3. And at this point, we see connectivity from VM to container and container to VM as part of the same OpenStack cloud using Neutron networks and across these two physical hosts, running Neutron with plumb plugin. And the communication is happening from Docker to VM and VM to Docker. So this was the basic part where we provision a network and with two VMs. Now let's go to the L3 domain where we provision a router. So similarly, all the Neutron operations, we provision a network and now we provision a router. At this point, if you go to the network topology, we see a router popped up in the topology. Let's go to the plumb side of things to see a router is also there in the topology now in the virtual domain, which is not connected to anything. Let's go to the router, add the interface on the subnet, which is attached to the Docker demo network. So interface got created. It has an IP address 192.168.0.254. And in the network topology on the horizon, we see that it's connected to the Docker demo network. Inside the plumb console, we see that the router is connected to the Docker demo network as well. And if we look at the IP address, it's the same one we saw over there, 192.168.0.254/24. So now let's go to the router and let's set gateway onto the external network so that we can have external connectivity. And then we'll ping Google DNS, we'll ping OpenStack arg from the VM and from the Docker and see how that goes. So at this point in the network topology, what we have is the private network is connected to the router and router is connected to the public or the external network. And in the plumb domain, we see a NAT is there connected to this router, and that's going over to the internet. So now let's go to the VM and ping something outside of this cluster. So let's ping 8888, and what we see over here is we are pinging from the VM inside this cluster over a network in Neutron through a router, a NAT, and going over to the internet. And similarly, we do the same from the Docker, and we see the same behavior. So what we have is a container and a VM connected to the network and is able to communicate with the external world. So we see let's ping openstack.org from the container, and that goes through as well with a lot of latency. That's probably because I'm running way away from that. Okay, so at this point, we saw that inbound to outbound connectivity from in to out connectivity works because of the SNAT. Now let's associate floating IPs to check from outside to inside connectivity. So let's associate floating IPs to both of these Nova instances. So I associate a floating IP as a VM and then associate a floating IP to the Docker container as well. Both of these IPs are coming from the external network. So I have two IPs. One of them is 192.168.122.36, and the other one is 192.168.122.39. I have a base host machine over here, which is other than the compute nodes. This base host machine is somewhere else. It is on the same network, which is 192.168.122.0/24. So I'm going to ping 192.168.122.36. So over here, I'm pinging over the floating IP from outside to over to this VM over this floating IP that is, of course, is getting inbound NAT translation. And similarly, I'm pinging the Docker container from outside to inside over these floating IPs. Now let's SSH into the VM from outside to inside. And let's see if that goes through. And yes, it does. Let's log in. See its IP address, which should be 192.168.0.3. And yes, it is, which matches the one in Nova. Perfect. Now let's exit and let's play a little bit with the security policies to see if traffic stops if we remove some of the security group rules. So I have ping going on from Docker to the internet, and I have ping going on from the host machine to the VM, and I'm going to go to the security groups and remove all the rules. Let's see if the traffic stops. So let's wait for these rules to get removed. And they did. The traffic stopped. It's not going through anymore. Not from inside to outside. Similarly, not from outside to inside. So all the connectivity has stopped because the rules are going away. All the rules have gone away. And we should not be able to connect to anything at this point over the network. So no more pings, no more floating IPs. And what we're seeing over here is security groups take effect for these containers and VMs. So what we have is, just to recap, a full topology with the external network and a router and the private network with these Nova instances, a Docker and a VM. And you have all the networking features which are offered as part of Neutron. And the way you see them in the plumb git console is something looks like you have a VM and a container connected to your DHCP or bridge with a router and NAT, etc. So with that, I'll shift back to my presentation. This was the demonstration part. So I'm back onto my presentation, and I would like to summarize what I just did in the demonstration. I provision a network, and then I provisioned two Nova instances, a VM and Docker container, on two different hosts. They were both connected to the same network I provisioned. And then I validated connectivity between these two hosts connected to the same virtual network. And then we added a router and then attached the router to the external network and the private network. And we checked external connectivity. We also tested floating IPs and checked connectivity from outside to inside. And also in the end, we actually looked at some of the functionality of security groups. So in the end, what you saw was a VM, a container as part of same OpenStack cloud, running in a unified networking layer with Neutron and PlumGit ONS plugin. With that, I would like to touch upon some of the steps which are not developed yet, or they are in discussion phases or design phases. And I'm pretty sure some of the people over here will have questions on this is with Nova Docker, but what about Magnum, Magnum is container as a service? So I'm actively contributing to the Magnum project. Magnum will have networking also coming from Neutron. We were at OpenStack Summit a couple of weeks ago, and we had discussions on how to solve that. So this is just in discussion phases. It's very early stages, but that's something we'll see how that gets developed. And by the next OpenStack Summit, we'll of course have something new to show you guys, a new demonstration. So what we'll have is that as part of Magnum, or as part of all the container technologies, there will be a common networking layer which could solve networking for VMs, containers, and bare metals, and we'll be able to plug in a way that all your use cases can be solved. And containers offers multiple, or Magnum offers multiple scenarios where you can launch containers, like container inside a container, or container inside a VM, or container on a host. Regardless of how it is being provisioned or how nested it is, networking should be common, and it should work very seamlessly the way I did a demo just now. I think with that, a summary of the session, I'd say Docker has finally arrived. It has been embraced in the industry. It is part of OpenStack. Networking for Docker has improved in the past, and we just showed you a demo of how you can have networking for Docker containers and VMs in a unified way inside OpenStack today. And also I shared how and what is happening now, and how we expect and what we expect to see in the next few months coming from the discussions we're having. And with that, I think I am done. Let's take the question and answer sessions.
Yes, there are a few questions for you.
Okay.
So the first one is the plugin open source?
So yes, the plugin is open source. Plugin is part of the Neutron. It has been there since the Grizzly release. So Grizzly, Havana, Icehouse, Juno, Kilo, and Liberty. It has been certified. If you go to Stackalytics, if you look for the plugin, you should be able to see it.
Great. Then there is another question. So how does container B disallow container A from accessing its socket? And I guess you can probably talk just a little broader on how is really this isolation built into the solution.
So Valentina, can you please repeat? I think you'll break up.
Yes. So the question that one of the attendees posted is, how does container B allow or disallow container A from accessing its socket? And what I was suggesting was maybe to broaden it up a little bit and talk just about, the isolation. How is the isolation enforced across different containers?
Yep. So if you have different containers, I'll touch upon the networking aspect. There's a lot of dimension and discussion and how this is there in the compute side of things or container side of things. I'll tackle it from the networking side. So from a network point of view, a container A or container B, if they want to talk to each other, in the end, they have some port where they're communicating. And let's say with plumb grid, what you have is policies applied onto those ports that you can control what container can talk to which container on which protocol and all of those things. So that's something can be applied as part of the policy framework. And you can have more discussions how that goes. But that's from a Neutron or OpenStack point of view, you have security policies to control that. And that should be done in the same seamless way. And that is where we're trying to drive the discussion in the Magnum community as well. And that's what I showed in the demo as well. And as part of plumb grid, we have a security policy framework, which can do much more than what security policies do, security groups do. But that's how you can provide isolation from a network point of view. Okay.
Great. There is one more question around DNS.
Mm-hmm.
How does the DNS work with external DNS services within the existing, within our network, so the existing network?
Okay. So just to give some background and information to all the folks over here, DNS as part of OpenStack is coming as a new or different project. It's called Designate. I have also been contributing to that as well a little bit. So Designate is DNS as a service of OpenStack. Designate has made great progress in the past. Unfortunately, as part of Neutron integration, the work is not there yet, and it's been in the air for last 6 months or 12 months now, and the priority seems not to be there for now. Let's see how that goes. So it's not there. Designate and Neutron integration, it's not there today. With plumb grid, what we are capable of offering is that DNS is inherently available as part of the virtual domains, and we have managed to allow users to provision DNS as a service through Neutron APIs or extensions. And to answer your question in the next phase, what we have over here is DNS virtual network functions, which can be used in different use cases. Let's say you have an L2 private DNS and an L3 private DNS domain. You can have split DNS over a NAT, or you can have DNS talk to the external DNS, depending on your implementation or use case. And we have some customers who are using them in that scenario.
Great. There is a couple more questions. This is a long one. So what is the status of networking in Magnum, and how are different deployment options like containers in a VM handled?
Good question. So Wednesday, OpenStack Summit, 20th May. We had a session at 3:30. I was part of that session, and the discussion was exactly on this point. Networking for containers inside Magnum. And Magnum is offering all sorts of container services, and how do we solve that? And there were different proposals, and what we end up agreeing, and I was proud to lead part of the discussion over there, is that Neutron has to solve this problem. The right architecture for tackling networking has to be done through Neutron, regardless of your provisioning containers inside a VM or containers inside a container or container on a host. I mean, the question over here is some people have application containers and some people have system containers. So regardless of how nesting is done, the orchestration or the API or the user interface for networking has to be Neutron. And the implementation details is something we have to figure out how to do it. So what is the status of it today? The status is in discussion phases. This is something we are discussing. We have to take it to the design phase, and then after the design phase, we take it to the implementation phase. So today it's at discussion phases, and this is where the community is at from a networking point of view.
Great. There is one more question, which is maybe a little off topic, but I think it will be interesting for the audience. Can you give us an overview of the different networking technologies that are available outside of OpenStack that provide solutions for containers?
Yep. So outside OpenStack, there have been a lot of technologies which different orchestration systems are using as per their need. To enumerate some, I'll go over, let's say Pipeworks was one of the technologies which was there, experimental open source. Then there's another one, Flannel. Then there's another one called Weave. So these are some of the networking options which are outside of OpenStack as part of, and some are used as part of Kubernetes, something is used natively with the containers. So they are there, and they're offering some use cases in a very limited fashion. Most of them are in early stages, and let's see how they evolve.
Great. There is one more question. What is the status of adding layer 3 connectivity to individual containers in Docker? So as part of Docker itself, if outside of OpenStack, if you want to have layer 3 connectivity, you're looking at some of the options with IP tables or routing, table implementation. That, again, I will go back to my same point. The orchestration is pretty, I'd say it's very primitive. I mean, you're managing it from a scripts or your own managed automation scripts, and it's very difficult to persist all of those configurations, and it's not really scalable or production ready. That's there today. However, the other point I made about libnetwork, libnetwork is designed to actually allow you to provision network topologies. And there's an experimental project called Docker Network on GitHub. That Docker Network, you can look at the code. What it does is that it allows you to actually write code to provision network topologies. And when I say network topologies, think or recall the diagram which I showed in the plumb Git console, where you have this switch connected to a DHCP, connected to a router, and all of those things.
So coming back to the main question, libnetwork is working on exposing L2 concepts right now, since it's very early stages. And we expect to see L3 concepts very soon as part of libnetwork as well inside Docker ecosystem. And let's see when that comes.
Great. I think these are all the questions. Deborah, back to you.
Okay, perfect.
Great. Thanks, everyone, for joining us today. We really appreciate you taking the time to listen to what Fawad had to say about this. Great job, Fawad. Thank you. We'll go ahead and send up a follow-up email sometime tomorrow, so you can look for that. And we look forward to seeing you at future events. Thank you.
Thanks. Bye.